Cool. Hello, NDC. I'm really, really excited to be here. This is actually my first time in Norway ever. So what a way to kick it off with such a massive conference. Thanks for coming along. So I'm going to be talking about securing the web with AI today. This seems awfully broad and maybe a bit crazy as a topic, but I think we're going to have a bit of fun. We're going to look at some cool technologies that maybe you have or haven't used, and how we can use those to help improve security in our applications day to day. So, a little bit about me. I'm Callum Whyte. I'm on Twitter, at Callum B. Whyte, and I'm a .NET developer. I speak at a bunch of events, this being one of many, and I also organize some too. I'm also a huge donut-driven development fanatic. You may not have heard of it, but it's just where you eat a copious amount of donuts whilst coding. I was told you have to start off with a really bold statement, so I'm gonna do that. The web is broken. In fact, these aren't my words. These words come from Tim Berners-Lee, the creator of the web. He wrote in 2016 a blog post marking 30 years of the web. And in it, he cited various reasons why he thought the web, as it is today, is broken and unfit. He said one of his biggest disappointments was that personal data gets breached all the time. And along with that, how that gets abused, and how people get abused through the internet. They get tricked, scammed, conned. It wasn't what he created. He created a tool for sharing information, and it's not being used for that purpose. Now, I say a lot about it being broken, but what do I actually mean by that? I'm pretty sure everyone here has heard of Have I Been Pwned, but here is just 3 examples from around the past month alone of cases where many millions of people's data has been leaked online. Most notably, the first one up here, the Club Penguin breach. This is kids, potentially. Like this gets really, really serious. There isn't really a week that goes by without one of these data breaches happening. As of this morning, this is the number of pwned passwords in Have I Been Pwned. It's a pretty scary number, nearly 500 million records. And the chances are one of your passwords that you use is in that data set too. Every time I have to visit family or friends or parents, they tell me, oh, I was online and I was told I had to download this PDF viewer, and now my computer's running all slow and I'm not sure what's happening and it didn't really work. Can you help? Chances are they've been tricked by one of these. I think some of these look particularly believable, especially the Flash one. Pop-ups that come up on websites, and if you're unaware or you don't know any different, they may look believable, and people get fooled and they go and click on them. A statistic, about 800 million individuals were affected by malware in 2018 alone. That's a scary number, considering about 3.5 billion people in the world are online. That's a huge percentage, around 20% of those people. It's pretty scary. I think this exemplifies why the web is broken, but it doesn't really explain the cause. I think it's our fault. As developers, we're responsible for safeguarding and preventing some of these things. We need to make sure that the web is a safer, better place for everyone. Security is often taken for granted, and in this day and age, that just shouldn't happen. It's not a privilege. Security is a right. We sign up to a website, we shouldn't expect our data to end up on some forum in 2 or 3 years' time. I don't want to be receiving emails from Have I Been Pwned. Some of the ways that we currently go about protecting our users would be more traditional. Encryption, making sure that internally within companies you have strong data handling policies, and also actively monitoring user activity. If they log in from a new location or from a new device or at an unusual time of day, maybe reporting on some of that. More recently, we've seen a focus towards requiring secure passwords and setting strict rules around those things, encouraging or discouraging reuse of passwords and encouraging the use of password managers to make sure that people have almost unguessable passwords, and also multi-factor authentication. I think these are some really big steps towards making people's online data more secure. But it's still not quite enough. How many people in this room have built a website that requires login and can honestly say they've implemented full multi-factor authentication support? Maybe you have in a few places, but how many of the login systems you've built that are out there have full multi-factor auth? Chances are very few. So we as developers are neglecting this responsibility to keep people's data safe. And I'm not saying that you have to do every single one of these things, but just maybe offer something. Data is really important. In the UK, there's a bank called Monzo. They're actually more of a tech company. They've built their entire banking architecture from nowhere. They're using Go and microservices, and it's all very, very nice and modern. It's not the kind of thing you expect from legacy banks. Now, back in April of this year, they noticed some suspicious activity happening in some of their bank accounts. All banks do this, but very few of these incidents can actually be attributed to anything. Maybe someone got your credit card details when you were abroad, cancel your card, we'll send you a new one. In this case, Monzo actually noticed that a bunch of people who'd used Ticketmaster within the past few months had then had money taken from their accounts unexpectedly. They notified Ticketmaster of this about mid-April. They visited their offices. They had a chat. Ticketmaster were absolutely adamant, no. There's nothing that's gone wrong on our side. By the 21st of June, later that year, Ticketmaster publicly admitted, oh yes, we did have quite a severe data breach in the many, many thousands. The fact that Monzo had this data and had the alerting mechanisms in place and the analytics in place to identify this meant they were proactive. They could contact their customers, cancel cards, and stop them losing money. A similar incident happened with British Airways. Their website got attacked and people were skimming card details off the page. Well, they identified about 1,300 customers of theirs that had been affected, proactively cancelled their cards and informed British Airways. This is a huge difference to the banks of yesterday. They don't do this. This modern technology company with all of their analytics can do this. But chances are most people in this room aren't running a bank, and we probably aren't building bank-scale infrastructure. So how can we implement things like this in our systems? Well, thankfully, all of this intelligent technology is becoming more and more accessible through services like Azure Cognitive Services or Google's or Amazon's offering, and technologies like Tensorflow, which is completely open source. These are becoming increasingly available, increasingly affordable, and also increasingly usable in terms of very low knowledge needed to actually operate them. You can call an API, get some data out, and you're doing AI, I guess. In the example of detecting abnormal behavior, something that probably most websites do, you log in from an unknown location, and we're going to inform you, that doesn't look quite right. Well, Azure now have an anomaly detector API. So very simply, you can chuck off 12 or more data points with a date time and a value, and it will compare all of the values and say, these don't quite look right in that set of data. And it's super cheap. We're talking 15 cents for 1,000 transactions. If you did this for every single login on your site, it's probably not going to cost you very much, and your users are going to gain quite a lot out of it. It's a case of calling their API or via their SDK, sending the JSON object off, and getting a fancy response back that says, we think this data is an anomaly or not, with a range, upper, lower margins. But just because you're doing this doesn't actually mean that you are helping your users. This is very reactive. The second someone has been able to get into their account, you're going to notify them that that's happened, but it's not going to prevent it happening in the first place. We're still neglecting this responsibility of protecting them in the first place. We're just trying to catch the bad guys later on. It's not really the way we should be doing things. I think we need to be more focused on the security experience. the user experience of security products, if you will. I think actually 90% of security isn't the encryption and preventing people getting into your systems. That's surely very important still, but we've been doing that for many years, and we're pretty up to date on that. As people building applications, I think it's 90% about educating our users to make sure that they're going to follow the right practices. This is actually happening already. This is a very prominent example from the past year or so, where browsers are starting to flag websites as not secure if they contain form elements, but the page doesn't have an SSL certificate. It's training users to start looking for that green padlock. And then eventually, they're going to replace the green padlock with just a message that flags saying, no, big red, this is not safe. And we're slowly encouraging users to start looking at that address bar and paying a bit more attention. It doesn't fix the problem of someone could create an SSL certificate that's not for the site that it says it is, but it's slowly encouraging people to pay a bit more attention. I found this online. You may not be able to read it. It's quite small. I really hope it's a joke. But you do see on some websites ridiculous, complex password rules. I'll just read a couple of these out. It must contain one letter, one number, one special character. The only special characters must be an @ symbol, a hash symbol, or a $sign. I think there's something in here. Other words that can't be used are Texas, child, and months of the year. I assume that's a joke. But you get the gist. This is a ridiculously complex set of rules around creating a password. They're needed, they're necessary. We have to have some restrictions. We don't want someone putting A, B, C, D, E, F as their password, of course. But maybe we can simplify that and make that a little bit more approachable for people. How many people got one of these on their GitHub account? I know I did. I log into my GitHub account and I get a nice big red banner along the top saying, you might want to change your password. Your password was found in a data breach in Have I Been Pwned? Okay, now we're being a little bit more proactive, notifying me, hey, someone has got your password somewhere on the internet. You might want to update that. It doesn't mean that GitHub's been hacked or breached, but the data in order to hack or breach your specific account might actually be out there. Thankfully, it's got a really nice API, and it's really surprisingly easy to implement. Again, things are becoming more accessible. The best thing is we're actually encouraged to use it within limits, and it's completely free to use. So if you needed to roll out some password checks on your website today, this is a pretty damn good place to start with the API. And I wanted to show quickly just how easy it is. I mentioned I'm a .NET developer. I mostly work with a CMS called Umbraco. It's for editing content. We run sites on that, anything from 5 users, and they don't get much traffic, all the way up to huge corporations. And that means that they're, some of them, quite big attack targets. You do a lot of work to make sure that the admin section of the site is not accessible to people that shouldn't get to it, but there's still times things slip through. And it's no excuse to not have proper security protection on the back office. In this case, this example, I've invited someone to come and sign up to be an editor of the CMS, to work with me on the site. They get an email, which I have here, and they get a nice link where they can go and say, hey, come and join. They get taken to a page where they have to choose a password. This would be a perfect opportunity to start guiding people to creating stronger passwords. We have a little bit of text here that says your password must be something like this. I think there's a small bug there because it says it must have 0 non-alphanumeric characters. But here we can hook into Have I Been Pwned and check that the values the user is going to give us actually are valid. So I've created a bit of JavaScript that will allow us to hook into that. The Umbraco admin section is built on AngularJS. So for this, you get to see my shocking AngularJS skills. All I'm doing is I am hooking into events. So when I leave, when the user leaves a field, I'm going to trigger a bit of code that gets the value, passes it off to an Angular service, which will then call the relevant APIs to go and get data. And if there's a result, it will display that to the user. I'm doing that for both email addresses and passwords. The passwords in Have I Been Pwned follow a K anonymity model. I can't. Yeah, damn. It's basically you send a partial string from a hash of their password. You get a bunch of responses back, and you compare that against all of those to see if the full hash exists in that data set, and if so, how many times. So under the hood, this is hashing the string. It's taking the first 5 characters, sending that off to the API, checking the response for the full hash, and saying if it exists or not. It's about 40 lines of code. If we look at that in action, I'm going to just choose a really bad password and run that along the top. Of course, that password, it was straight across the top of the keyboard, has been pwned many, many times. This is a really nice example of a user experience. It's not invasive, and if they really want to go ahead and use this password, they can. There's nothing stopping them from submitting, but it's just giving them a hint and saying, hey, maybe you want to check this out, just like a validation error on the form. And just in case they don't know what the word pwned means, there is a link they can click, and it will open and explain exactly all the stuff that's going on. But of course, that's not AI. And you're all here because you want to see some nice examples of using some of this fancy new technology to achieve cool things. Well, one of my biggest bugbears is two-factor auth or multi-factor auth, because it means so many things to so many different people. So many companies I've seen, oh, we've got two-factor auth on their roadmap, and they end up implementing SMS-based authentication. And the security experts will go, well, that's not secure because someone can spin up a cell tower and hijack any messages coming in. Then you have app-based, but no one seems to be able to agree on one app to use. I think I have about 5 multi-factor auth apps on my phone. There's phone calls, there's a bunch of different ways. There's a few downsides to two-factor auth, being you probably always have to have a phone with you or some kind of physical device, and maybe you don't always have that, or maybe you don't always have cell service. You're completely screwed if you lose your phone or your authenticator config. And does anyone actually keep hold of those recovery tokens that they give you? Maybe a few people. But for every single service that gives you 10 tokens, do you really keep track of all of them? It becomes a bit tricky. And the codes expire pretty quickly too. But I think the worst thing about this is so many acronyms. Like, how do you explain two-factor authentication to your parents, or to a grandparent maybe? If we're saying security should be a standard, is this really an approachable mechanism for people? I'm a little bit of an Apple fan, sorry. But they have done something really good with Face ID. This idea that you can unlock your phone with your face, and it's got a bunch of 3D scanners and things inside the phone to do an infrared scan, and then it stores a mathematical model of what your face looks like, and then you can authenticate with that. The setup experience of this, in my opinion, is really, really slick. The fact that you just move your head to their instruction, they get a nice map of your face, and then can use that to authenticate. It's really, really accessible, really easy to use. They've got a bunch of other stuff like Siri in the phone, as Google have and Amazon have as well. And these things also understand your voice, and you're training up an AI under the hood. Becoming more popular, we have 3D sensors like Intel RealSense, which is Windows Hello in the Surface Book, or Kinect. Microsoft recently released a Kinect developer kit, so you can start building those yourself. In the real world, how can we replace these technologies? I'm not Apple. I'm not going to go and build a face sensor and make everyone that wants to use my website carry that around. It's just not realistic. But there's a few APIs that we could call with some data to say, hey, maybe you can help me out with this task. Azure have a fantastic face detection API in their cognitive services. They've also got a brand new speaker detection service, which is in preview currently, and the Azure Connect developer kit, which I mentioned. So we're going to try and identify some faces. with Azure Cognitive Services and see if we can use those as a way to authenticate, or at very least replace a two-factor auth system with someone's face. The way that it works is you have to give it some frames, either a still image or a video, and you split that up into stills. You can then call off to a trained model to say, do you recognize anything in this data? Of course, you have to train that model first. Training a model, this is C#, so if anyone doesn't understand, I'll kind of just walk through it quickly. The idea that you pass an image off to an API, it comes back and says, yep, I've got that. You say, OK, please train your model on that image and recognize that person as this ID. They call it a group ID. So this is saying, this person in my system, or this user, is this picture. They then go off, does its training asynchronously in the background, comes back saying, yep, I'm all done. Off you go. You're then free to go and query that. So I take in a stream, in this case a file stream. I can pull the images that I've been given out, pass those off to the API and say, do you recognize anyone in this photo? And if it does, it comes back and it returns that person. I can then, on my side, in my application, compare that response and see, does the person that's come back map up to the person that's trying to log in? And of course, I built a demo of that. Because this is a complete live demo, it could go horribly wrong, but let's try. So again, within my Umbraco site, what I've done is I've created a two-factor authentication provider. Umbraco's .NET, and it uses OWIN for authentication. If you don't know about .NET, that's fine. You probably don't need to worry. Any authentication provider pretty much has a way of plugging in some kind of two-factor auth provider. I've built a bespoke one here, which I've called FaceLock. What it does is it calls off to the Azure Cognitive Services and passes any data I've sent it off. It checks to see if it's got the faces in it, the code you just saw, and then comes back to me with a response. I'm dealing with this in AngularJS, just like before. I take a response from my web API. I pass it off through a bunch of methods to say, here's all the stuff you need to do, and then I come back and say whether they were authorized or not. This is the stuff that passes it off to Umbraco. You don't need to worry too much. In this case, I'm grabbing a stream from the webcam when the auth provider kicks off, and I'm then starting a timer to say whether it is ready to go or not. It gives the user 3 seconds to say, yep, put your face in front of the camera, let's see if we can identify you, and then sends that image off, and if they're successful, they proceed. Let's give it a go. Because I'm a great developer and I take security very seriously, I have an incredibly secure username and password. But this is now going to ask me to show my face. Oh, hello. OK. Something went wrong. Never mind, but you get the premise. The idea that I can capture some images from the webcam, pass those off to Cognitive Services, and it will come back. It even gives me an option to retry and keep going up to a limit of 5 attempts. Of course, this is mega flawed. Like, this is not security, really. We're taking a feed from someone's webcam and passing that off to an API. If I held up a picture of myself on my phone, chances are it would probably authenticate that, and that's not hugely safe. It can be tricked super easily. Actually, a website just randomly turning on the webcam and saying, hey, can I have a picture of you, is a bit creepy. And if it slides on the phone because it's there and you're kind of expecting it, but the webcam's used for so many things on your computer, it's probably not going to work. And imagine being in a meeting and everyone getting their laptops out, trying to log in and having to go, ooh, and it's just going to look ridiculous. Also, some people just don't want to show their face. You might be self-conscious. They may have disabilities that mean they can't move their face or something, and this might cause problems. So yeah, it's a bit difficult. I think the biggest concern here is that we're passing some potentially sensitive data off to Microsoft, to their AI platform. I trust that they've done everything they need to do to keep that secure and safe, but one day someone might breach that API, and we might have a bit of a problem on our hands. I hate to see the day where Troy launches, has my face been pwned, has my voice been pwned, has whatever I've given to this auth service been pwned.com. It's possible that it could happen if one of these services did actually get breached. Okay, so let's think of some potential solutions to this. We could require some more unique actions. This way we can prevent people just holding up a picture. If every time I log in I'm required to do something relatively random, well then we can detect that through the API. The API understands certain movements, it understands emotions that your face pulls, it understands speech. I mentioned they have a new preview service for that. And we could even detect just other things like your background. If your background is one of 3 different places because you're in an office, then sure, we'll let you in. 3D sensors, okay, we have some 3D sensors. If you've got a Windows computer, you've probably got a 3D sensor, but the chances are most people don't have these, and this is going to become a bit of a problem. There's also, as far as I know, no easy way to get 3D data from one of these sensors in the browser. You would need special drivers, and it gets complicated. We could also try and process some of this data offline and do some of this machine learning offline, trying to prevent the need to go to the cloud, even send any data to a third party. Stuff gets exciting now because I get to talk about some relatively bleeding edge technologies. WebOffN is a web authentication framework for the browser, and Tensorflow.js is an AI or a machine learning tool built in JavaScript. They've ported it from Python, I believe, over to JavaScript. So WebOffN is pretty powerful. It's supported in Chrome, Firefox, and Edge to varying degrees. I don't think anyone's been able to quite agree on a standardized implementation just yet. There's no Safari or mobile support. So if you wanted to support this technology as a way of authenticating, you're going to need to provide a fallback. It's a mechanism for exchanging U2F tokens, which are the tokens that a YubiKey or something generates to say, this is me. It's effectively an interface for the browser to interact with security hardware, such as a YubiKey or Touch ID on the MacBook, or maybe even your face on the phone. Because the device is controlling all of that authentication, it's just doing some cryptography to send a token, which is pretty powerful. When I try it on the internet in Chrome on my Mac, because it has Touch ID, it actually says, do you want to give me a USB security token, or do you maybe want to try your built-in sensor, such as the touch sensor? And when I do that, it says, hey, you're trying to authenticate with touch. Do you want to just tap the sensor or use your password? And when you've done that, it generates the token, sends it off to the server. My two-factor auth service, instead of spinning up the webcam and saying, hey, show me your face, could just call some of the JavaScript to trigger a WebOffN session. That's pretty powerful. Tensorflow.js is really cool. I mentioned TensorFlow is a Python-based machine learning tool built by Google. This is a JavaScript implementation of that, which seems like a crazy thing to say, but it's happened. It's WebGL accelerated, meaning it's pretty fast, but your CPU gets pretty hot when it's running. It's a way of running any TensorFlow models or ported TensorFlow models in the browser, and then you can do machine learning. You can even build up your own neural nets and do some fancy stuff there. They have a great GitHub repo with some pre-trained TensorFlow models that we can then download, reference, and use in our own applications. Something that particularly interests me is this idea of detecting things with the webcam for security purposes. In this case, they have a library called Coco SSD, and it's for exactly that. It's object detection. It knows about 90 different objects, and this is a JS port of the version that exists for TensorFlow Core. You can pass it an image or some videos, and you can also specify how detailed you want it to be. depending on how hot you want your computer to get. The API is so accessible. It's 3 or 4 lines of JavaScript to actually detect something. Pull in Tensorflow.js, pull in the model. The model gets spun up with this load command, and then you can call a detect method to say, here's my image, tell me what's in this image. That seems crazy powerful. And just like before, I actually have a quick demo. So I made my auth provider to be entirely pluggable. I can pass in a few different parameters to say the kind of things I want it to do, such as I want to authenticate with my face and an emotion, or my face and a random phrase, or, in this scenario, an object. What this is going to do is it's going to trigger some slightly different code. Instead of spinning up the webcam and calling cognitive services, it's just going to spin up my Coco SSD machine learning model. It's going to pass my current webcam into that machine learning model, and then it's going to go through every single frame that it receives, chunk it up into static images, and try and detect something on each of those. For the sake of making sure we don't spam the machine learning model with a bunch of photos that it's identified the same person several times, I'm keeping a list of the objects we've identified, and every time something gets added to that list, it goes off to the server. It says, was this the object you're expecting? It's limited on both sides, so you shouldn't be able to misuse it. And then, if it's come back to say, yes, this is the thing I was expecting, it will let you in. I said it understands 90 different objects, and I've set my object to be a water bottle, just because why not? We'll try it first with a couple of different objects that won't trigger. In my wallet yesterday, I tried my room key for my hotel. It thought it was a refrigerator, so this is going to go well. But it will spin up and it will say, please show me your secret object. The webcam loads once Tensorflow has triggered, and it's probably now seeing me. If I hold this up, it's probably going to identify that as a refrigerator. But if I hold up my water bottle, let's try that. Oh, it did identify it successfully. OK, it just triggered something wrong first. So it's then being able to say, look, I know you've held up a water bottle. We can probably do that once more just to show you that I'm not actually lying. It will spin up the webcam. It will load Tensorflow. And I'll hold up the water bottle straight away. It's identified a water bottle. That's incredibly powerful. At no point does this call an API. This is all happening natively in the browser, which is really, really insane. So we've done some really cool stuff now locally without having to call off to any APIs. One of the biggest issues of the current time, maybe 2 or 3 years, has been fake news and rubbish on the internet. You can't really believe anything. And I actually think that this is part of a security concern, because people will believe the Flash downloader image that pops up and makes you download anything, and they'll also believe anything they read. There's a few techniques that have been around for many, many years, but now with powerful AI, we can start doing a bit more with these. Error level analysis is a technique for detecting different levels of compression inside images. What it lets you do is, if you have a big JPEG and you strip back all of the compression data, you'll get a kind of a black and white picture of all of the different places where colors change. Compression algorithms for images squash similar colors together, and they become one big block. And therefore, if you strip all of that data out, you just get left with the blocks and the outlines of those blocks. It means that you can detect when something's maybe been overlaid over an image at a different compression rate, because one image has been compressed at 50%, and the new thing is only compressed at 20% over the top. So you can actually detect that outline. This is an example of some image data. So this image on the left-hand side is of a bookshelf, and someone has turned one of the books around, and you can kind of pretty clearly see the outlines of all of those objects. And if we really strip that compression data back, increase the level of compression, it starts stripping more and more of that away. So, oh, that color is more similar to that, we're going to start stripping that out. And now you can pretty much see an outline of everything that's in those images. Someone has photoshopped a nice dinosaur over the top of that image. They've actually also just gone and put a new book in here, or turned this other book around. There's a few different things that have changed. I've taken these images off Photo Forensics. If you're really interested in this, go and have a look at that website. It's pretty cool. So this was the image compressed before, and this is actually the same image at the same level of compression. We can see the new things that have been put over the top, or even in this case, some things that have just been moved and turned around. We can actually see the difference between those images. It would be really, really cool if we could find a way to make some of this technology accessible to our users, so that they can take advantage of the added knowledge of being able to identify when something's real or not. I went and looked into all the different implementations for this, and unless you want to get super deep into C and proper image compression, it gets really messy. But some people have made some APIs and some tools. There is a tool on photoforensics.com that lets you do this and compare the different levels of compression. But I was particularly interested in this blog post here, where someone made an HTML5 and JavaScript implementation. Because everyone has a web browser, and everyone's browsing this content in a web browser. It would be really cool if locally on the device we could go and do these checks. Well, this is effectively the code that they use. So they're using HTML5 canvases, and within that, they're pulling in the original source image and mapping that onto two different canvases, and then with that, adding different levels of compression and comparing the results. In this scenario, I've been able to pull this into a Chrome extension, because it's just manipulating DOM elements in JavaScript. And what I can then do is I can, for any image on any web page, find out exactly what the compression data for that looks like, and at varying levels of compression. This becomes really cool when we bring some AI into it, because we can now decide how photoshopped has this image been. Through the custom vision API, which is available through Azure, you can pass off images and tag them to say this has been manipulated, this one hasn't been manipulated. This is all doable via C# or JavaScript or whichever language you want, or even just by posting stuff to the API. We start to train the model to detect different things. I actually attempted to see if it would just be able to identify different colors. In this case, if anything has been heavily compressed, it should be black, and anything that hasn't, it's going to be a lighter color. So if we can check to see what the prominent color in an image would be, if it's mostly black, then chances are it's not been compressed too much. However, it's not very accurate, because as you can see here, this image has very clearly been modified, but at half of the image is still black, so the predominant color is black. And we need to come up with a better solution. Again, Azure has a really powerful API to say, I'm going to detect objects in images. And in this scenario, it's able to identify, hey, that is a toy in my image. I get a nice JSON object back that says, this is the position of the object I identified, and this is our classification of that object. Comes back with a confidence score. It might find things that definitely aren't in there. So I think here I'm filtering out anything that's less than 50% sure, and it's going to report back. It's not coming back and saying, definitively, this is broken. You shouldn't be trusting this image. It's kind of going to come back with a percentage to say yes or no, should you believe this or not. And then if we look at the demo that I just showed of using Tensorflow to pick up objects in images, we can actually forego Azure completely here. We could literally just call that TensorFlow JS model and say, can you detect any objects in there? It's not going to be as accurate as the AI models on cognitive services because it's on a much smaller data set, but it has pretty good potential that you don't have to call an external API. So, of course, it would be cool if we could show you this. I decided to go for a relatively non-offensive website, I think, to see if we can test this out. I've created this Chrome extension, which I've called Fake Finder. Really catchy. For anyone that hasn't built a Chrome extension before, it's JavaScript and a manifest file. The manifest is saying, here's all of the stuff that I need to be loading in when the browser runs and when the Chrome extension's active. And you supply it with a JavaScript file. In my case, I have main.js and client.js. Client.js posts the stuff off to the API, but it could equally just be calling TensorFlow. You register a bunch of events to say Chrome when you check on an image or you check on a bit of text, maybe. Register this context menu. And that context menu then has an event, so when you click on it, it will go and trigger your code. Ooh. There it is. So the BBC website has a bunch of images on it, and now I think we can pretty safely say that image has been manipulated. It's probably not a real photo of space, sadly. So I've registered an event where my fake finder will show up. And on clicking check fake image, it's going to go and call the code, and it's come back with a score. It says that's 50% accurate. So this is a pretty rudimentary example of calling some AI in pretty user-friendly way. You'd come up with a nicer pop-up than that, but yeah, saying the AI has predicted that this is about 50% modified based on the compression data. So if I can give you a few takeaways from this session, my big points would be that a lot of security is about education. Don't forget the value of making sure that your servers are safe and secure, but we need to be thinking about some different ways that we can get people engaged. Let's stop talking in acronyms. Let's stop making people install millions of apps and trying to get them to set it up. It should be as intuitive as pulling out your phone, using the face sensor, and being able to log into something. Technology is progressing very quickly when it comes to this. WebOffN is only something that was starting to be implemented last year. So maybe in a year's time, we'll have a full suite of JavaScript libraries we can use to call native authentication services. I think your two weapons that you need really to combat any of this is an API and JavaScript. And you may not even need the API. You can use some really powerful stuff like TensorFlow to build super slick, nice security experiences. I demoed just a few of them, but maybe you've been inspired by other things you can implement. And I'm not saying that these are to create Fort Knox type security, but it's an added layer on top of existing authentication mechanisms, like secure passwords. And then we can use APIs and JavaScript to further encourage people to create those secure passwords. Cognitive services and other AI technologies, WebOffN, Face ID and the physical hardware that we can use, and tie that all together with some AI like TensorFlow, it becomes a hell of a lot easier and accessible. I hope that this talk has showed you that this doesn't have to be scary. AI can literally be 3 lines of code nowadays. All of this code is available on my GitHub for you to go and poke around, and I will, of course, share the slides if you're at all interested. We have quite a bit of time for questions, but I would love to chat with people about some of their ideas, criticisms, concerns, and thank you very much for listening to me. We can do questions, if anyone has any. Will I be around? Of course.
You mentioned voice recognition for Amazon Alexa. Does it exist also the Echo device?
So the question was, voice recognition in assistants like Siri, Alexa, and in Google Assistant. I believe they are only just starting to roll out the actually identifying specific people across all of these assistants. I know Siri's only got it with the coming update. Whether or not they're available via the API, if that data is available, I'm not sure. I couldn't comment on whether specific devices implement that or not. But I would hope that the more that these technologies become widely adopted, that they open these APIs up as much as they possibly can. Yeah.
Make sure that's only that necklace.
Absolutely. So a great example would be you always sit at a specific desk in a specific office, and there's certain objects in the background. You might have a certain potted plant. Now, because this is just a base model, you can add stuff to that model. You could start training your own model based on all of that data. So if you wanted to start trying to recognize a specific object, you could. Generally, if you're going to try and train an AI, you need a bunch of data to do it. So this existing model has been trained on a pretty large data set. If you want to train your specific thing to recognize it, it might be a bit more tough. I tried to get it to detect thumbs up or thumbs down, and it had a bit of difficulty with that. As you can probably imagine, just depends on, it's the same image, just in a different orientation. And I gave it about 200 samples, and it still didn't quite pick it up. I think at that point, this is where you should go to something like Cognitive Services, where you can give it, but it's got a much vaster model, and someone's probably put a similar necklace in there before, so it can identify that that is a necklace, and then you can kind of further specialize the AI. Cool. If we're all done with questions, I'll be around for the rest of the conference, happy to answer anything. Thanks again for coming along.